we're starting at 7:40, so we have a little bit of time for the last people to enter.
Yeah, that's what it says on the email I got from Terry.
Is there any questions or topics that we can handle in this open meeting or subjects for the meeting of the minds?
There is a small issue that on the public calendar, it said we were going to do this with Google Meet.
Great.
You want me to check and see if anybody's on it?
Yes.
Okay, I'll do that. Go ahead, don't wait for me.
All right, real quick, Mike, anybody who's interested in doing stargazing in about 10 days on Saturday night, September 12th, it looks like they're going to be clear skies. The moon's not going to rise until 1:45 in the morning. So that would give you 6 hours of stargazing. A suggested location is the Agua Fria National Monument, 50 miles north of Phoenix. It's a Bortle 2.5. So it'd be about an hour drive for anybody in the valley. And so I will send out a notice though, but especially for Pete and Eric and Howard and the others that usually like to go out to those things.
Yeah.
But anybody else, if you're interested, contact me or I'll send out a notice closer just to make sure that 10-day weather report looks good, but you never know.
What's the Bortle up there, did you say?
Bortle 2.5, 2.5.
Okay. So it's a nice, yeah, that's a possibility.
Yeah.
Sure.
That sounds great.
So it'd be Saturday night, September 12th. It gets dark enough to see things and photograph by 7:45, and at 1:45 the moon rises, so that you got 6 hours to work with. Okay,
Alex
thanks.
donated his 11-inch scope to the club, and I have it here at the house, along with an 8-inch Dob that was also donated to the club. But it takes 2 people to move it out of the house. It's available for our next star party out at my location. But
Hey, John.
the guidance doesn't work.
John,
The
this
block
is
drive
Pete
doesn't work.
On Google Meet. We're not doing this on Google Meet. We're doing it on Zoom. You should go to your email. There should have been an email that came out around 5 o'clock tonight that told about this. That'll give you the link to get to Zoom. Okay?
Pete, you don't have your Zoom muted.
Yeah, let me get that muted. Sorry,
You don't have to.
guys. I'm on both.
Oh.
We're still getting used to this, Klaus.
Oh, yeah. I know the feeling. Yeah, we have the same issues up here. And I guess it's sort of a toss-up between which one of these systems is best. Zoom seems to be pretty steady. It doesn't cut out very often, which is and simple to use, I guess.
Yeah, it seems to be the most reliable.
Hold on, guys. I can't find. I'm trying to talk to here, and I can't find the Zoom meeting.
You're wrong.
Coming through loud and clear.
You want the numbers?
I'm on both, unfortunately.
But I can read out the numbers if you like.
You get an email from me on the pass list? No, I did not. Okay.
Peter, do you want me to read out the numbers?
Sure.
Okay, the meeting ID is 819 4589
4589
0366. And the passcode is 523793.
Did you get that, John?
I didn't get the last 4 numbers of the ID. Was it 0366?
0366.
819-458 90366
Correct.
523-793.
is the passcode. So if you go to zoom.com and join a meeting with that information, you'll get to us. Okay?
Thank you very much.
Okay.
Thank you, Pete.
Now I got to get back to the meeting. If you don't come in, John, I'll come look you up on Meet again.
All right. People are concerned about the notes from our meetings of the minds. Do you have notes?
I have notes. I haven't written them up.
Okay.
Had a little project that I was working on.
Let's record the meetings of the minds from now on.
I think that's a good idea, but notes are good too.
Yes. Okay, I'd say this is close enough to start the meeting. Again, I don't have my bell to start the meeting, but I think that we can start right here. Klaus has actually talked to us before. From what I can see, most of the people here tonight have seen you before, so you're known to us, Klaus.
Yes, I recognize some of your faces too.
Yes, he volunteers at the Lowell Observatory in Flagstaff, and he's going to be talking tonight about the Clark telescope, 24-inch. I love those brass telescopes. When I was in college, we fixed one up and the professor said, "It's beautiful. It's mine now."
Well, I think you'd have a hard time commandeering any of Lowell's antiques. They're all on the National Historic Register, so they catch you quickly enough.
Are you worried about that wooden dome with all the fires that occur in that area?
Well, of course, fires can occur anywhere. We've had, in the past several years, there've only been one that was reasonably close. Of course, the wooden dome wouldn't stand a chance, so to speak, but one of the good things is that the Lowell is, of course, a city treasure, and fire department would be there in no time. Well, they have been in the past whenever there's something. So, of course, everybody's concerned. And right now, Coconino National Forest has absolute complete shutdown on any fires and so on. But you never know about lightning strikes and the like. So it's always a danger. And right now, of course, as you guys have and as we have, we've broken all kinds of heat records and all kinds of drought records. And yeah, it's concerning.
One of the observatories had a fire right up to the building.
That's right. Lick Observatory.
Yes.
And a few years ago, Siding Spring Observatory in Australia was nearly wiped out by wildfires. Trouble is, their observatories are on mountaintops and dry areas surrounded by trees.
Well, I'll stop interrupting and let you get started. I think by now, everyone who's going to show up, it will be here.
All right. Well, I shall then cut myself out and share the screen, and let me know if I'm getting through, okay?
And please, everyone, mute.
Can everyone see that? Just give me a nod.
Yes, I can see it.
Can you hear me too?
Yep.
Yes.
Yeah.
All right, very good. Well, actually, I've changed my topic a little bit to be broader and simply refer to as the research legacy of Lowell Observatory, because there's so much that's been made open in the archives of late. And I thought I would share all of that with you. As you can see from this pictures, on the left is our revered founder. And on the right is an imposter who tried to strike the same pose with the 24-inch Clark telescope. And when I first visited here in 2005, that's me, obviously, unless you are confused by the two. And that's always a good one to start with. All right. Now, before getting into the detailed subject matter of the Lowell research and telescopes, I want to remind everybody that preceding the establishment of Lowell Observatory, the century before that, basically 1750 to 1850, saw tremendous technical advances in research equipment and astronomy, so that it was now possible to do way more than just the visual work, which was really the prime stuff done before that. And some of the key things that were developed in that century was the development of achromatic lenses and learning how to silver coat glass mirrors. And these two technological applications immediately improved the optical quality of telescopes orders of magnitude. In addition, diffraction gratings and spectroscopy were developed. And as you all know, spectroscopy is probably the single most powerful tool that astronomers rely on to this day. Also, and much of this was the work by a German physicist and inventor, Joseph Fraunhofer. He developed the first German equatorial mount with clock drive, so that telescopes could now follow objects. And this beautiful instrument here was built in 1824 by Fraunhofer, and it really set the stage for what subsequent refracting telescopes really would look like. This was a 9.6-inch diameter achromatic lens objective. And as you can see, here's the German equatorial mount. And as clock drive mechanism, he simply had weighted pendulum type things to track and assist with that. This particular telescope is still in existence in Estonia, where it was originally established in the observatory there. And the other major technological breakthrough at that time was, of course, photography. Now, as most of you probably know, the first type of photography, the daguerreotype, which involved wet plates as opposed to dry plates, was developed by Frenchman Louis Daguerre in 1844. And the first reliably dated photograph that still exists today, 1837, was a still life that took several hours of exposure in direct sunlight because these wet plates were so incredibly slow. It took a very long time for all the photons to actually register as an image. Nevertheless, very quickly, this technique was applied to astrophotography. And here is American astronomer J.W. Draper. Many of these people were amateurs in their day. And this is the first daguerreotype of the moon, of the full moon, taken in 1840. And as you can see, it was remarkably good and detailed. And so very quickly, photography became the instrument of choice to record data, because drawing and sketching continued for quite a while longer, but it was clear that photography would gradually win out. Very quickly, from daguerreotype, which were really horrible, toxic fume things that it's amazing the photographer didn't inhale stuff and die, was incredibly slow, and they didn't last very long. So very quickly, the technology advanced from the wet plate to dry plates. And what you're seeing here is an image of the moon taken on dry plate. And you notice it has very good resolution and detail. And this was taken by J. Whipple in 1851. Over here, you see the first effort at deep sky photography. this less than flattering image is actually the trapezium region of the Orion Nebula, and probably took several hours of exposure just to register that. But again, it was a great advance to be able to do that. And what really launched photography in the public mind was actually this invention here by Warren de la Rue, 1862 in Britain. And he started making these stereoscopic photographs. And during the Victorian era, you may recall these little things where you could see stereo pictures with two lenses and two images became extremely popular. And as a pastime, because they didn't have TV or radio, so this was a lot of fun, obviously. And that really launched photography on a commercial thing, which really helped develop it further. Around that same time, and this atlas of lunar photography was published in 1903 from Paris Observatory by these two gentlemen, Lowery and Puisieux, and they developed a fantastically incredible telescope. Hopefully you can see it in detail. It's kind of a small image here. This was at Paris Observatory too. It had a siderostat, a mirror here, which would catch the moon. Then this was a refractor. The image would be sent into this telescope, reflected back into this cabin back here, where the photographic plates were, so that the observer could actually see inside and in complete comfort. And this particular atlas, published in 1903, believe it or not, this was the standard best photographic atlas for another 50 to 55 years. There was no improvement beyond that, largely because film in those days, and plates, of course, were very grainy. So until films and emulsions improved, there wasn't much chance of improving the actual quality of these photographs. Now, the other key element that really launched Lowell Observatory and all the research was, of course, the infamous 1888 apparition of Mars, where Italian astronomer Giovanni Schiaparelli had a superb telescope. He was an outstanding astronomer with all kinds of comets and minor planets and other things he had discovered, so he was highly regarded. And the 1888 opposition of Mars was one of the best in the modern era, and he had a very good telescope, so he tried to map the albedo features, the dark and light features, on Mars in great detail. And because he seemed to see these streaky features on Mars, which he called canali, which in Italian actually means channels, but was soon translated into canals, with all the implications, of course, that canals have. Now, because of these reports by Schiaparelli, Percival Lowell, who was not an astronomer, was actually trained as a mathematician, and he came from a wealthy textile family in Lowell, Massachusetts. He wasn't interested in business, but the family, of course, had lots of money. And Lowell became kind of a world traveler, and he spent time in Japan and in Korea and wrote about them. And then when he found out about Mars and its canals, he got the bug and immediately decided that he was going to spend the rest of his life studying astronomy. And he had the means to actually afford the Alvin Clark and Sons to build him personally one of the then largest telescopes in the world, the 24-inch Clark. It was not the largest telescope in the end, because the 36-inch at Lick and also the 40-inch at Yerkes eventually were larger. But Lowell decided that he didn't want to set up in Boston or on the East Coast, because he realized that in order to have dry, clear skies, you have to move west. And so eventually he ended up in Flagstaff, as everyone knows. Here's the telescope, a picture of it in 1905, and it really hasn't changed very much. The dome, interior, etc., is still wood, and the dome rotates. Initially, it was mounted on railway wheels, but then in the 1950s, that was replaced with truck tires. Anyway, I'll tell a little more about that later. Now, Lowell may have been infatuated with Mars and its canals, but what he also did is he hired a number of really outstanding astronomers at the time, including this gentleman, Karl Lampland, who was German-born originally. And Lampland was a terrific tinkerer. He made all kinds of instrumentation that was used to measure the temperature and brightness of stars and planets and so on. And he developed the first early photography. As you can see here at the bottom, this is one of the original cameras that he made. And here's some of the prints made from that. What the advantage was of this camera, he had a sort of 4x4 glass plate, and he would be able to take at least half a dozen or more exposures sequentially of a given planet. And so if seeing conditions improved, or if he wanted to insert filters, color filters, and so on, he was free to do that. And so here are two of his early 1904 photographs. This is Jupiter, and of course, this is Saturn. So he was truly, an incredible innovator. He also, Lampland also experimented in deep sky photography. And over here, you see, if you've been to Lowell, this is a telescope that's now set outside because it's essentially unusable. That was also, the optics were built by Alvin Clark, and it had a 42-inch mirror. And with that, Lampland was able to actually take some rather incredibly detailed deep sky photographs. So you can see here, this is the Trifid Nebula in Sagittarius, taken with this telescope. And down here, you see a rather small image of Messier 51. And in those days, keep this image in mind, because in those days, nobody knew these were external to our Milky Way galaxies. These were referred to as spiral nebulae. And I'll return to that topic again in a little bit later. Now, the reason canals, and we may laugh at Lowell today and others who thought they saw canals, artificial canals on Mars and so on, and of course they were deluding themselves, but it was also in part really due to the technology of the day. In the 1800s, because before trains were invented or widely available, the only way to get around in many places was by building canals. And for example, in England, and you see this is a postcard at the time, in England, they built something like 6,000 miles of canals in this small country, and that was mostly used not for irrigation, but for transportation, for people and goods, etc. And then in 1869, the Suez Canal was built, and of course in 1900, the Panama Canal was built. So these were really earth-shattering developments because they affected commerce and travel, etc., in a very positive way. However, also, in North America, both Eastern Canada and the United States, all kinds of hundreds and hundreds of miles of canals were built. The Erie Canal, a whole series of them to join cities and places of interest through waterways. And so at the time when Lowell Observatory was established in the late 1800s, Arizona was, of course, still a territory, and of course, it was a dry desert. And at the time, the desert was essentially considered a wasteland. It was useless. And so if you ever get a chance to read some of the historic newspaper articles in the Prescott newspaper at the time, there was all sorts of discussion about how the desert would bloom and turn it into useful agricultural lands by building canals. So the whole focus was on canals. And consequently, when Lowell started seeing canals on Mars and arguing that they were in fact built by intelligent aliens, that didn't scare people very much. It was sort of in line with the philosophy of the day that if they were Martians, they would probably be more advanced than we were, and they would have canals all over the planet. And that, in essence, was what drove that entire sort of fantasy at the time. And one of the things that Lowell was so keenly interested in before photography was that he was desperately trying to photograph these canals, which of course he depicted as very thin, skinny lines, which would, if they were true, they would be way beyond the resolution of a 24-inch telescope on Earth. But he also tried photographing it, and here you see a 1907 picture of Mars, and you can see that there are some faint, sort of very fuzzy, wide-looking areas, and these they thought were canals, or that they had photographed the canals. And what also happened in public imagination, of course, in 1898, H.G. Wells in England wrote War of the Worlds, which in Victorian times must have scared the daylights out of people, because people were in fact convinced, thanks to Lowell and others, that there were intelligent aliens, a dying civilization on Mars, which was tapping its polar caps to bring water to the desert equatorial areas. And here's a depiction of what Lowell thought they would be. And the reason he thought he could see canals is because you have a waterway and then you have vegetation growing around it, and that would be wide enough for him to be able to detect. I remember when I was a kid in Toronto, seeing the 1953 movie of The War of the Worlds, which was one of the most best made studio movies at the time. I'm sure many of you have seen it. It scared the living daylights out of me with these fantastic machines that were unstoppable. And we still sort of have a bit of a sense of, you know, are there aliens out there who might somehow do us harm, et cetera, et cetera. So we've still stuck with that romance of possible alien invasions. As we now know, of course, there were no canals on Mars, but that is not to say that everything that Lowell and other of his contemporaries observed on Mars was pure optical illusion. For example, here's one of the albedo maps of Martian dark features that was finished in the 1960s and 70s. And here is one of the Mars orbital images, or made into a map. And you can see there's a fair correspondence between the dark features and the ones that have been recorded on Mars. And also this particular structure here was reported by many observers at the time. They called it the Canal Coprates. And actually we now know what they were seeing is the dark layer of material associated with Valles Marineris. Likewise, another structure over here is called Kerberos, is actually this one here. And if you look here, for instance, this dark layer, this was also recorded at the time as canals. And of course, what they are is wind-blown areas of dust and other things, and contrast between different layers of soil and sand, etc. on Mars. So it wasn't all fantasy, although most of it, of course, was. I had a lot of fun, and my first time that I had a chance to actually do some photography through the Clark telescope was on a visit in 2003, when I had my first digital camera, a rather small Nikon, and I think it had all of 3.3 megapixels of resolution. And I knew where I was looking. And you see here this fuzzy little thing. And here in one of the old images taken by Lowell, you see the same kind of thing here. Well, that's this region right here. So it was within reach of photographs. It just wasn't a very fine, thin superhighway-like canal. Now, after Lowell basically passed, one of his other main interests, and this is where he does deserve a lot of credit, he's convinced that out beyond the orbit of Neptune, there was another planet. And so he undertook 3 separate searches for this planet X, as it was called. And he was convinced that this would be a large planet, roughly the same size as Uranus or Neptune. And he calculated where that might be based on the then imagined, really, perturbations in Neptune's orbit, which, as it turns out, really weren't there, but he didn't know that. And after he had passed in 1916, Vestal Slifer, who was then the director of Lowell Observatory, decided to continue this search, in part because the observatory had taken on a rather bad reputation worldwide because of the canal fiasco. And so they were trying to very much, turn their reputation around into more serious and better science. And that's how come Clyde Tombaugh was hired. He was a young high school student who happened to send some observations that he had made with his own telescope in Kansas, sent that to Vesto Slifer, and Slifer decided this kid's got promise, and so they hired him. And so he, of course, as history told us, in 1930, he discovered Pluto. Here is the discovery plate, and you can see it's been animated to show you how Pluto moved within a period of about a week in consecutive plates taken by him. We now, of course, know several things about Pluto. One of them is that it's really a very small body. But from the New Horizons flyby, all sorts of things were discovered that nobody would ever have guessed prior to the New Horizons flyby. Namely, that it is a very interesting and unusual planet, that it has all kinds of surface activity, which nobody expected. Everybody thought it'd be a frozen Kuiper Belt object. It is frozen, but it certainly is not inactive. And so in part, of course, that's what led to its being declassified as a planet to being a minor planet. If you're up visiting Lowell next, be sure to catch the fully refurbished 13-inch astrographic telescope, which was used to discover Pluto and to do a lot of other photographic surveys that have been done since at Lowell. This is really quite a historic instrument as well. Now, what about Pluto? The argument is that the IAU, of course, demoted it because it very likely is, in fact, a Kuiper Belt object that was captured. As you all know, it's got the most inclined orbit relative to all the others, and it is the most eccentric orbit as well. And so that suggests that at some point in the past, it was bumped into by another Kuiper Belt object and maybe came too close to Neptune and was gravitationally captured. What makes Pluto, however, so interesting is that it probably represents very much what the primordial material of the solar system was like and what it consisted of, etc. And in addition to being very interesting in terms of its composition and etc., which would take another whole lecture just to clarify, it also has Charon and several other moons, which make it incredibly interesting as well. Now, Vesto Slifer's younger brother, Earl C. Slifer, also an astronomer, was also hired by Lowell. And he was mostly dedicated to his interest to photographing the best possible, obtaining the best possible photographs of the planets. And among other things, he developed what today we call image stacking, but in those days was called integration printing. And you can see here a photograph of Saturn taken in 1948. Here's a single exposure. And here are 10 images printed together. And as a result, what he managed to achieve is to reduce the graininess in a single exposure and also enhance contrast to reveal more detail. And he subsequently applied this technique to all of his planetary photographs. And here you see some of his very best efforts. This one over here on the left, top left, is Venus as it is about to enter inferior conjunction. And what he did was quite a tricky photograph because he could show from this, here's of course the disk of the planet, but he was able to demonstrate that the atmosphere refracted the light all around the disk and that the atmosphere is very thick and refractive, even though we can't look through it and see the surface of the planet. Here's a beautiful picture of taken in 1938 of Jupiter. And you can see here the moon Io is in transit, and you notice all kinds of detail that had never been recorded before, really, until this integrated printing was adopted. Here's another beauty taken in 1946 of Saturn. And here is one of the best photographs ever taken of Mars in 1941, a particularly favorable opposition of Mars, and showing all kinds of nuances and difference in intensity and structures that had really not been photographically recorded before. So Slifer was really, EC did some phenomenal work. This method of image stacking was first taken by Harold Johnson and others in 1958, again, using the 13-inch Pluto astrograph. And again, remember in those days, color photography really was in its infancy in terms of astrophotography. And what Johnson et al. Did was to take here's a single 45-minute exposure on the plate, the large plate, I'm only showing you close up, of Messier 33. And then if they took 10 of these and stacked them together again through printing, you can see how much improvement there is in terms of more detail, sharper looking stars, less noise, and in fact it gained about 1.5 magnitudes that would never be recorded on a single exposure alone. And to show you how far we have come digitally, I try to emulate this with my C11, and I took at a digital camera, and I took 10 3-minute exposures and stacked them together. And you can see that there is a lot more information in digital imaging today than could possibly ever be done with black and white photography at that time. Now, Vesto, the elder brother and director of the observatory after Lowell's death, really is one of the great astronomers of all time. He has not gotten enough credit, as many of us probably realize by now. One of the problems with the Slifer brothers, after Lowell had passed, they became very, very reluctant to publish anything for fear of ridicule because of the bad reputation that the observatory had with the canal story. And also the observatory was in dire physical, financial straits. So these astronomers there really couldn't devote all their time to astronomy, they had to go out and get other work because they couldn't survive otherwise. So it was really kind of a sad era in the Lowell history. However, returning to earlier times, Lowell was convinced, as I mentioned before, that the spiral nebulae, or spiral galaxies, as we now know, that were faintly visible visually and photographically, they had no idea that these lay outside of the Milky Way, because at the time, at the turn of the century at least, it was generally considered that the universe, our galaxy, was the entire universe, and consequently, any object that looked sort of spiral, whatever, had to be inside our Milky Way. And Lowell was interested in how planets formed, and so he thought that these spiral nebulae were actually young solar systems in the process of being formed. And because of that, and because spectroscopy had become the new tool of astrophysics, he commissioned Brashear and others, the Brashear company rather, to build this beautiful, if you've ever had a chance to see it, it's an absolute masterpiece of sort of early 20th century workmanship. And basically here you see Vesto having attached it to the eyepiece end of the Clark telescope. And what he would do is take photographs of the spectra of these faint spiral nebulae. Now, for those who may not be familiar with how spectroscopy was done then, basically here is a cartoon illustrating the visible portion of the spectrum broken from, infrared to violet. And what astronomers used at the time, and still do really, is a reference spectrum. Here, for example, these two dark lines, the color portion of the spectrum, the vis, is called an emission spectrum. But if you have material in the way, then you get an absorption factor, in other words, these dark lines. And these would be generated in laboratory studies using elements like calcium and iron to get a reference point that you could then compare to the spectrum of the galaxy that, or other object that you might have taken. So Slipher spent inordinate amounts of time. In many cases, it took up over 40 or 60 hours of exposure to get enough of a signal onto film for the spectrum of these faint nebulae. And then in 1914, he published his results and in fact presented them at the 1914 annual meeting of the American Astronomical Association. And here's what he found. Now, just as a reminder, in case you've forgotten, there is the Doppler effect, which applies to spectroscopy as well as sound. And again, just to be simplistic, as you know, if a siren or a police car or ambulance comes towards us, the sound that it makes is very high pitched. And once it gets past us, it's low pitched. So it goes wee and boom like that. That's the Doppler effect. When the automobile or the vehicle is coming towards us, all the sound waves are compressed and they give you a high pitch. And once it goes away, then it's a low pitch because they're then slowly coming at you from the vehicle having passed. Well, the same principle applies to light and the Doppler effect. And what's possible from this kind of reference material, this kind of reference information, is to actually calculate the radial velocities or the rate at which an object is receding or moving towards us. And to his immense surprise, Slipher, when he looked at, for example, the Andromeda galaxy and the two little, and the little companion and Messier 33, he realized that they were not moving away from us, but their recession velocity is like 300 kilometers coming at us. Also, Messier 81, another prominent and bright galaxy, it too had a negative recession velocity. But all the others were essentially receding from us. And if you look at something like M104 or M51, M104 is receding at us at the phenomenal speed of 1,100 kilometers per second. And when he saw these numbers, at first he didn't believe them. And then he recalculated and remeasured and came up with these values. He realized that these spiral nebulae couldn't possibly be within our Milky Way. They had to be outside of it, because over a time period of a few years, they would have, just disappeared from view at that rate if they were inside the Milky Way. So he made a major discovery, and he didn't quite know what to make of it. But anyway, he presented his results at the 1914 meeting. And in the audience was a gentleman called Edwin Hubble. And Hubble was a young upstart astronomer then, but he was working on Wilson Observatory. And he realized, of course, that he had access to much bigger telescopes there, namely the 60-inch reflector, and then by 1918, the 100-inch reflector, which of course was the largest telescope in the world for a very long time. So he did the same thing. He took plenty of spectra and plotted them in terms of distance and velocity. And if you see here, this is 1,000 kilometers per second, 500 kilometers per second, as a function of distance. And of course, on that basis, he realized that these galaxies were receding from us. And that ultimately gave rise to our expansion of the universe model. And that's another very long story to go into in any detail. But that's essentially how that came about. And Vesto Slipher laid the foundation for that and has only been recognized posthumously for this tremendous contribution and discovery of his. Now, the next phase of the Clark refractor's major research productivity happened during the space age, basically from the late 1950s well into the 60s and 70s. One of the programs that is also not well known by many people, but was tremendously really cutting edge in its day, was the International Planetary Patrol Program. And this was run by William Baum, a brilliant astronomer at Lowell. And he convinced observatories around the world to basically be able to do essentially around the clock observations of the bright planets, and to do so on a very sort of repeatable and standard basis. So all the telescopes that were used in this process were 24 to 25-inch aperture. They all had similar focal lengths, and Lowell developed a series of cameras that would actually electronically take film-based pictures, but the timing was great. So here, for example, you see a patrol sequence of 1 24-hour period of Mars. There was an observatory in Chile, and then in New Mexico, Lowell, Hawaii, Australia, etc. And you can see the full rotation of Mars taking place, South Africa, and then Chile again. And so then this way it was possible really to monitor planets around the clock and look for specific either weather changes or other changes. And these cameras were equipped with filters that would take pictures in red, green, blue, and ultraviolet light. And here you see a series of images of Mars taken at the same time through green, blue, and it said essentially the ultraviolet and blue only show you the upper atmosphere and clouds, whereas red light is longer wavelengths, so it really is from the surface and shows albedo features and dust storms. And here Venus was photographed in ultraviolet light, and it was possible from that to determine that the cloud deck on Venus actually rotates at quite a different rate than the planet itself, which was quite a finding as well. And here's the network. As you can see, it was scattered around the planet. Here's Lowell, here's Hawaii, here's New Mexico, here's Chile, here's South Africa. India was also involved, and then 2 places in Australia. It really involved a lot of people and much effort. Here is a typical telescope that was used at that time, in addition to the Clark telescope. This gentleman here, Dale Cruikshank, is a professional astronomer of great repute and a long-standing friend of mine. And here he was a youngster working in Hawaii on part of the Planetary Patrol program. Dale is now, he's close to retirement, but he's very much involved in the whole Pluto New Horizons program as well. So he says he's going to die, he's going to work until he dies. He's a great guy. One of the things that the Planetary Patrol program was great at determining was the whole business of when dust storms would appear on Mars. As you can see here in this color image, this is pre-dust storm, and then here day 1, you start seeing a bright spot here. Day 2, the spot has increased. Day 3, it's taken up half the planet. And by the time we're done, day 8, it's totally obscured. And it really didn't clear up again until basically, 3 weeks later. So this is the kind of work that was being done then, and it was really very, very pioneering in its day. Here you see a series of photographs of Jupiter done in ultraviolet light, where it looks very different, and they were able to trace the development of different storms and so on. Over here, I've thrown in pictures taken by a good friend of mine and one of the best amateur lunar and planetary imagers, Leo Ayerst. He lives in Belgium near Brussels, and these images of Jupiter were taken from his backyard with a C-14 and some very, very good cameras. And as we can see now, the resolution, etc., that modern technology provides just blows all the older stuff out of the water. But that's progress. Now, the final major scientific involvement of the 24-inch Clark was in the photographic atlas of the moon in the 1960s. Here you see Gerald Kuiper, who was at the Lunar and Planetary Lab at the time, and he was in charge of the program, and what he wanted was to take the best available photographs at the time and develop the most detailed map of the moon in preparation for the Apollo moon program. And this involved a number of outstanding as well. Here you see, for example, Gene Shoemaker, who I'm sure all of you are familiar with. He established 2 great important things. Number 1, he showed that our beloved meteor crater is actually not a volcanic or of volcanic origin, but we proved definitively that's an impact basin. And based on that, he was working for NASA and the U.S. Geological Survey. Based on that, he was put in charge of the USGS astrogeology program here at Lowell. I mean, here in. Hello, is there any question, anybody? Oh. And what was still the case then at the time is that despite the fact that many large telescopes produced beautiful photographs, they were still very grainy in comparison to what can be done today. And so telescopes like the Clark telescope were used to visually add additional detail to make more detailed maps. Here's, for example, Ewan Whittaker was one of the prime movers behind that. And then these two Canal and Bridges were working at the Clark refractor. They would use a basic thing like this, which would be a reproduction of the best photograph available, and then they would fill in finer detail that you could only see by eye. And so this was really a very helpful kind of thing for the Apollo program. Now, in the 21st century, the Great Telescope has taken on new importance in terms of public education and other things. And here you see yours truly being able to use it for some imaging. And this is Kevin Schindler, for those who's the Lowell, a good friend of mine and the Lowell historian. And we had a few nights of fun using the Clark for lunar and planetary photography. Here are some of the first efforts of mine taking photographs of Saturn. What I wanted to do in this project, these were taken in 2005, again with the first digital camera that was really worth it, a 3.3 megapixel Nikon Coolpix. And what I wanted to do is to see whether a digital camera could, vastly improve of what the best photographs of Slipher's and others could reveal. And this is where I discovered that one of the problems with the classic achromatic refractors, like the Clark, is that there's a lot of chromatic aberration, or a lot of false color. And in order to get rid of that, one has to do a lot of image processing. So here you see the unprocessed image. Here is one that's been processed. You notice I've sharpened it up and sort of done a little better with the color. And then here's one in monochrome. And because I wanted one of direct comparison to the best that Slipher was able to do. And I think he's better than I was, even at that in 1946. However, with a better DSLR camera, higher resolution, I've since been able to play an occasional sequence of photographs. As you can see, the telescope, if you shoot in monochrome, as long as you don't shoot in color, chromatic aberration is not a big issue. And you can see the fine optics of this telescope under good seeing is a close-up of a portion of the lunar south. Here's a region of the moon that most of us are familiar with. These three beautiful craters, Theophilus, Cyrillus, and Katharina. And here's an image scale. This is about 100 miles. And you can see so nicely here how Theophilus is the youngest of these three craters because it has the sharpest outline of its wall, plus it impinges on this one, which is on Cyrillus, which is much older. And then Katharina is probably the oldest. It barely has a wall left for reference. So this is one way of getting relative dates, of course, of lunar craters. Here are some pictures I took of the Arzachel, Alphonsus, and Ptolemaeus region, which is one of the favorites of anyone who does visual work. And here's a zoom in of Ptolemaeus, this beautiful flat plain. It's about 120 miles across. And notice how I was able to capture incredibly fine detail by stacking half a dozen images together. And in fact, on a scale, this crater here, this doublet, is about 3 miles across, and you can see fainter and fainter stuff. I don't know if you can make it out there, but I probably resolved down to half a mile, which is really pretty amazing. And here's one of the best maps of the Apollo era that was made from visual and photographic work, and you can see this is. Comparing it to my photograph, I've actually recorded more than was recordable, even visually in those days, because when you start stacking images, of course, what you're doing is you're kind of cheating and managing to minimize the effects of bad seeing and turbulence in the atmosphere. I show you this picture because this is, again, the best Shoemaker's 1964 image of Copernicus. And you notice this little doublet crater here, named after Philip Fout. And here it is here. This is a webcam image that I took, the last one I took through the Clark a couple of years ago. And Philip Fout is actually a famed lunar observer in the early part of the 20th century. He was the last of the great visual observers. And he's, as it turns out to be, is a great grand uncle of mine on my mother's side. So I figured I'd have to show that off. Now, what about the next 100 years? Well, here you see the Clark. This is Ralph Nye, who was in charge of the complete restoration. The Clark now is beautiful, fully functional again. And he was giving me a tour of all the changes that have been made. And now, of course, the telescope hopefully will last another 100 years and give a lot of pleasure to visitors and others who are able to look through it. In the meantime, Lowell Observatory has moved on, as you probably know, now with a high-tech advanced telescope, the Lowell Discovery Telescope, a 4.3 meter mirror. Here's Jeff Hall and some visitors giving us a tour of this telescope. And of course, it is incredibly high-tech, especially designed for both wide field and deep space photography. It's a very versatile instrument and is well equipped with all kinds of equipment, modified equipment. Here are a couple of the images. This is the galaxy taken with the Discovery Telescope. And here's M13, and this is the galaxy, the Deer Lake Galaxy Group. Very pretty picture. And Lowell is continuing to expand its public program as well. And if you haven't had a chance to visit yet, the Giovanni Open Deck Observatory is slowly opening again now that COVID is stepping aside, and it has an assembly of several outstanding instruments. And this whole barn-like thing moves over, so the telescopes are all mounted here, and visitors could come and look through different types of telescopes at different objects and so forth. And Lowell currently is in the process of building its huge additional complex called the Astronomy Discovery Center, which will feature an outdoor planetarium and all kinds of other goodies that I think you will all enjoy when finally things reopen for full. And that's the end of my talk. If any of you are interested in reading up a little bit on some of the topics I touched on, including image stacking, this is an article of mine in the March issue of Sky and Telescope, then one about the International Planetary Patrol, January 2016, Lowell's Great Refractor made new in March 2016, and then the photographic legacy of Lowell's Great Refractor recently in 2018, and then an astronomy magazine, and then Canal Mania in Sky and Telescope, July 2018. So I thank you, and if there are any questions, I'll be happy to try to answer them. Let me minimize this. Okay. Let's see what we can do now.
You can just do a stop sharing.
Okay.
That was a great presentation. Thank you so much.
Oh, thank you. I'm glad you enjoyed it. Let me just
enjoyed it.
Let me just close the PowerPoint here.
Yeah, just go on your share screen and stop sharing.
Stop sharing. Oops. There we go.
Yep. Still got
I can't see all of you, so what do I do next?
You're still sharing your screen.
Yeah, I'm trying to get rid of that.
Down the bottom.
Down the bottom?
Yeah, you'll if you hold your hover
Oh,
over
yeah.
the bar.
Gotcha. All right.
There we go.
Oh, there I see everyone. Thank you, Klaus.
Well, you're welcome. I hope you could hear everything and see everything. It's the first time I've done this by Zoom. And if you have any questions, please feel free.
Well,
Yes,
it was
yes.
a great walk down memory lane because I started learning astronomy from Slifer and other professional astronomers.
Oh,
in
you did?
1960.
That's wonderful.
6. My parents were into astronomy. My father worked at a planetarium. We built an observatory. We did astronomy events every month from when I was 6 on.
Where was this, Mike?
Grand Rapids, Michigan. I grew up in the Grand Rapids Museum in
Okay.
the local B. Chaffee Planetarium.
Oh, that's neat. That's terrific.
And we built the James C. Bean Observatory behind the house we were building.
Wonderful.
Which the city of Grand Rapids purchased 2 years ago.
Good. Yeah.
So
Well, I started, of course, I started amateur astronomy in Toronto and then in Montreal, and I was a member of the Royal Astronomical Society. And we had some very active groups and clubs there. And eventually I joined the ALPO, which you may be familiar with, the Association of Lunar and Planetary Observers. So I was all set on going to college, becoming an astronomer. But as I mentioned, mathematics, especially advanced calculus, was not my forte. And so my next love was fossils. So I said, okay, I'll become a biologist. You know how you make these life-altering decisions on the spur of a moment. And I really haven't regretted it because I've always kept up my interest in astronomy.
My father taught Percival Lowell's ideas about canals on Mars until the 70s. And when the Mariner pictures came in, he ran to the books to find the canals. What a disappointment.
Yeah, I know. Oh, I think secretly many of us were, you know. Apparently, I don't know if you've heard this story, but Carl Sagan, you know, when they sent the what is it, the landers, the first landers, I forgot the name now. They were looking for life.
Surveyor?
Pardon? No, before then. Oh darn it! In '76.
Mariner.
Viking?
Vikings. Thank you.
Viking, yes.
And apparently, one of the reasons he insisted that they put a camera on these spacecraft, on these landers, is because he still secretly hoped, and apparently he said this when the first panoramic surface views were sent back by Viking. Carl apparently said at one point, "Gee, I'd give anything to see a tumbleweed roll by." You know, because clearly everybody was still somewhat hoping, well, maybe it's not that different, you know, from Arizona or something. But yeah, and E.C. Slifer really still believed the canals, he didn't think they were artificial, but he still believed canals were real up until his death in 65, 66. You know. Yeah, it was a tough image to let go of, and in part because, you know, I don't know if you remember, Mike, but some of the others, you know, when we were looking at Mars through small telescopes and in the good old days, you were convinced that those dark features were greenish, and you know, because of course there was a contrast effect. And then the bright polar caps and so on. I mean, it just looked so like a nice little planet that should have canals and life on it. And who knows, it may still have microbes on it deep down once we get there again, you know.
Yes.
As my friend Bill Sheehan keeps saying, the romance of Mars that started with Schiaparelli, we still have that in the back of our minds, kind of hoping, you know, that, well, maybe we'll go there and find bugs. And who knows? Yeah. Yeah,
Still
those
a challenge.
those nostalgic days were a lot of fun. I remember growing up in Toronto, there was a really one of the, at the time, the biggest telescope in Canada was David Dunlop Observatory, which belonged to the University of Toronto. And when I was a teenager in the 60s, in the 50s there rather, it was still dark enough. The observatory was about 30 miles north of Toronto. You could see the Milky Way. And during the 1956 apparition of Mars, which was one of the closest, people would, every Saturday night they'd have, public viewing. And I remember I was so excited. We'd go out there and you had to get tickets to get in line, and then standing in this 74-inch telescope, gigantic thing looking, impressive. And guess what they showed us instead of Mars? Albireo. Which I could see in my 3-inch refractor, But yeah, those were exciting days, really, in many ways. But I think you can't beat the excitement today. One of my continuing interests was when I got my my first job as an assistant professor in biology at Queen's University in Kingston, Ontario. One of my colleagues in physics was a radio astronomer, Alan Bridle, and he had actually been one of the first people to be funded in Canada to do a SETI search. This was shortly after the whole program was started by Frank Drake and others.
Yes.
So Alan got money and permission to use what was then the largest radio telescope in Canada to actually look for SETI signals. And of course, he didn't find any, but he gave a talk to the local astronomy club, and I went there, and he gave a great talk, and I started asking questions when he was finished, and our conversation continued well into the night. In fact, we ended up going to the nearest pub to continue talking about, SETI and life in the universe and so on.
Hey, they did. LPMs, remember that?
Yeah, I know. Oh my God, right? But what that led to, which is very interesting too, is a couple of years later, Alan contacted me and he said, Klaus, you know what I think we should do? Why don't we offer a course at the university? Now we're talking 73 here, which is a long time ago. Why don't we offer a course called Planets and Life? I'll do the astronomy and you do the biology. And I said, yeah, that's a great idea. So I went to see my department head and asked him if it's okay if I teamed up with this astronomer to give this course. And my department head looked at me and he goes, this isn't about little green men, is it? And I said, no, it's going to be real science, etc. So I pick up the phone. I'm about to pick up the phone to call Alan because I got the okay. And Alan calls me and he says, I just spoke to my department head and he's okay with it. And you'll never guess what he asked me. This isn't about little green men, is it? Because that was so foreign then, the idea of sort of having an astrobiology kind of course. And now every university in the damn continent has that. Good. Because they've turned out to be incredibly popular with students, and it brings in non-science majors, and it brings in anybody who's got the imagination and the interest. So that was fun, yeah.
I want to make a call for questions one more time.
Yeah.
Does anyone have a question for Klaus? Wow.
Well, obviously, I've answered every question. That's a first.
We are familiar with Lowell Observatory. It's
of course you are.
For us.
Absolutely.
What did you say, Eric? Whoever said that, I couldn't hear.
I didn't say anything.
Oh, okay. Any
Let
other?
Let me ask one question, Sam.
Yeah, hi, sir.
Hi, Klaus. Have you been to Lowell in the last month or so as to seeing them actually let people look through the telescopes again, or are you still doing just the virtual?
They have started, what they'll do is you can apply like groups of 10 people can apply to, they won't let in more than one, to the Goto Center, you know, the picture I showed you.
Right.
And then what they do is everybody, they put a little petri dish over the eyepiece, and between observers, it's wiped clean, and everybody has to wear masks. And they've got about 8 or 9 telescopes there, and apparently they've done some very small star parties of that nature.
I see.
And that's about all they're going to do now, because you know, if you start looking at the projections and the percentages and so on, in Arizona, we're not out of the, you know, we're not out of the woods yet in terms of COVID.
So
And
do they incubate the petri dishes to see what grows?
no,
I'm just kidding.
the petri dishes are used actually like a lens, so it's
Okay.
actually pretty clever.
Right.
Because you can, you know, they're completely transparent. So they put this over the eyepiece, you go up there and you take a look and you say, okay, I can see that, thank you. And then one of the educators comes by and wipes it clean for the next person to look through.
And are they required to sign any kind of waivers or anything like that?
No, what they do is everybody has to wear a mask, and of course they take your temperature, and then they're asked, you know, have you been sick? Have you this, that, and the
Nice.
other?
Okay.
And everybody, you know, there's like 8 or 9 telescopes, so everybody is only at one telescope at any given time, and then they rotate. So far that's worked out quite nicely, but everything else really is shut there. So.
Okay. Thank you.
Oh, you're welcome. Hopefully, Jeff Hall is very, very cautious, and I don't blame him, because, you know, even if you have a handful of cases coming out of there, that could, you know, basically mean that you don't know, unless you can trace them, you don't know whether any of the educators were affected or any of the staff, and, you know, so it's not worth it right now to risk that, and I think they're correct. Until we get word from, you know, the health department that we're out of the worry, I think playing it safe is probably worth it, even if it's sort of overkill, really. But, you know, the trouble too is, like, for example, I wouldn't be going there. I mean, I'm a high risk, in the high risk group. Most of us who are in their 60s or 70s or thereabouts are in a high risk group. So you don't really want to do any exposure until you feel perfectly safe.
Plus, I have a question, if I may.
Yeah.
Elon Musk and his internet satellites.
Oh, yeah.
Can you speak to that issue, please?
Sure. You know, we have Jeff Hall is co-chairs one of the IAU committees that is dealing with Musk and with the Starlink issue, and the other companies that are thinking of launching, you know, tons of satellites. And it really is, it's a mess, because at least Elon is, he's listening, as Jeff says, and they're trying their best to attenuate the level of reflectivity, and maybe putting an anti-reflection coating on the satellites, and also making sure the antennas don't point directly down on Earth to reflect things. Eventually the hope is to send them into higher orbits so that will no longer be visible to the eye, at least. But, you know, there are no regulations international.
Klaus, you got cut off. You're on mute.
Unmute. There we go. Can you hear me now?
Yes.
Good.
Yes.
I don't know where I got cut off.
That was yeah, there's
No regulations.
Right. There are no international agreements. And it's, in radio astronomy, there is, for example, in terms of what frequencies are protected, like the 21 centimeter frequency. Nobody, there's no TV, no FM, nothing broadcasting at that. So at least radio astronomy is covered, but not optical astronomy. And so I don't know where it's going to go. Jeff is reasonably optimistic that Musk and SpaceX are trying their best to mitigate and minimize the impact. But no, if somebody doesn't want to, there's nothing you can do about it. Because there's no international agreement prohibiting that, and part of the problem is, if they were lower, of course, then you could say, well, you're entering national airspace, and that's forbidden. But if you're up at 200 miles or higher, well, then you're in international space, and so any regulation there, like flyovers and so on, don't apply. So that's a real concern. And hopefully some compromise can be reached, but we don't know yet.
Thank you.
Oh, you're welcome. Yeah, I mean, can you imagine if we suddenly have the whole sky covered with these wretched things? Especially, I find it annoying because, there are easier ways of actually getting internet across. You don't have to have a mesh of satellites out there. But I guess that's progress, quotes unquote. Yeah, the International Dark Sky Association is fighting it. The other good thing is the IAU, of course, is. And as far as I know, the Russian Academy of Sciences has thrown its objections in there. So if we get more and more international input, then perhaps, that something can happen. And if any of the other companies want to do the same sort of thing, at least they've been forewarned that if you're going to do this, either make your satellites less visible or launch them into higher orbits. But yeah.
I remember Echo days that the military tried to launch a rocket with 1 million nails to reflect radio waves off of, but it crashed into the Atlantic.
Oh, that's too bad. Well, you see, this is the other thing. I mean, we really don't know. And one of my local friends is a retired rocket scientist who worked for the Air Force in their satellite spy program during the Cold War. And, he says there's so much, as he puts it, SHIT up there that we don't even know who it belongs to. And we keep track of it to make sure it doesn't collide with one of our satellites or is about to burn up and so on. But there's an estimated 40,000 pieces of space stuff out there, And
I haven't read it.
Yeah, so.
An electromagnetic device will electrostatically change the orbits of the material it passes next to. All you need to do is elongate the orbit so that the debris intersects the atmosphere.
Yes, and then we'll have fireworks for several weeks as everything is burning up.
Fireworks on election day.
That's
true. 6 or 7 foot asteroid.
That's right. Yeah, and unfortunately, I don't know how we're still here in Flagstaff holding on to our wonderful dark skies, thankfully, because the city continues to cooperate in the International Dark Sky idea of International Dark Sky City. And we also have our Flagstaff Dark Sky Coalition. We're constantly lobbying and making sure that, outdoor lighting is kept within regulations and so on. But to be honest, Flagstaff has grown so much since we retired here in 2006. And I'm way outside on the east end in the Donny Park area. Partly we moved there because I wanted to build my observatory. But the Sky Dome is developing tremendously. Even Flagstaff is, getting to be heavy light pollution. And so it's a constant struggle. Now they're replacing many of the the high pressure sodium
LED.
with LEDs. And again, Lowell and the Naval Observatory and the university and amateur groups and so on are working closely with the power company to lower the output of the LEDs and put amber filters on them. And they're willing to do that. So at least, one can keep a bit of a handle on things, because at least that yellow light can be filtered out with light pollution filters. But it's a constant struggle because people see growth, growth means more light, more people, more traffic. And Flagstaff has been discovered, unfortunately.
We have
Tourism comes in droves, and of course the local people love that. It's good for the economy and so on. And we've got monstrous amounts of student housing now at NAU, because when we were here first, the university had 15,000 students. Now it's got 30,000 students. And they need to live somewhere. And so it's all these massive big apartment complexes are going up just for students. And it's a struggle. Fortunately, we can still get outside the city and go to Grand Canyon or Sunset Crater and so on, and have truly pristine dark skies. But if the Starlink crap comes up, then who knows?
We helped Tonto National Monument become a dark sky site, and I'm happy to say that Cave Creek has become a dark sky site.
Yes, I heard about that. That's great. Well, the other thing that's encouraging is, for example, Page and Winslow, two small towns that need resources. They're all starting to do the same thing because they want to be part of a sort of eco-astro-tourism and attract people out there to go to these monuments and enjoy them under a dark sky. So those are and also all of our national parks, at least out west, are slowly converting to being dark skies. But it's going to take a while to retrofit, and if budgets are tight and whatever, then it's a struggle. It's a real battle. But hopefully,
I'm trying to convince Cave Creek to also improve the road, the one dirt road that leads into the 10-mile wide crater we have here.
I know you guys have a crater. I wasn't aware of that until recently.
Oh, then you've heard about my ideas, yes.
Well, not in detail. No, I just heard what you were saying a little earlier.
Yeah. The material is here too, but it's mixed in with the rock. It melted.
Yeah.
But the iron is here.
Oh, that's great. Is that cordoned off in any way, or do people know? Is it an effort to maybe protect it, keep it away from off-roaders and so on?
Say that last part again.
Is there any protection in place to try to preserve it, to keep it away from crazy bikers and so on riding all over it?
It's too rugged for anything but horses.
Oh, well, that's good. That's good.
It's part of Tonto National Park.
Oh, yeah.
Unfortunately, the part where the iron went into the ground is being developed with multi-million-dollar homes. But it's 10 miles across, so just a small part of it is being developed right now. It just happens to be the most important part.
Well, isn't that always the case? Yeah. Well, this is, like I keep saying, it's a constant struggle because right now they're trying to develop, outside of the Grand Canyon, trying to open up development there, in Tusayan at least, and also they want to do uranium mining, right? And it's always a struggle. How do you protect the national treasure when there's so much money and push involved? And unfortunately, our current administration isn't helping very much.
Sam's son lives in Tucson as a Grand Canyon guide.
Yeah.
If you want a great tour through Pink Jeeps, ask for Frankopedia.
I will keep that in mind. Sounds good. Sounds good.
Hey,
Gentlemen, I'm going to leave you. Thank you very much for your attention. I thoroughly enjoyed it.
Thank you for the lecture and the information.
We can do this again at some point if you like.
Yeah, it reminded me of so much of what I saw in the 60s.
Yeah, I know. Yeah, well, have a look at a couple of the articles that, the Sky Telescope articles that I wrote. There's more detail in all of those, of course. So I think you might enjoy reading them.
And congratulations on having an asteroid named after you.
Well, thank you. That was quite a surprise.
Did Rick and Dolores Hill do that?
Pardon?
Did Rick and Dolores Hill do that for you?
No. Actually, it was Larry Wasserman, who is one of the older astronomers there, and he was one of the people who was involved in the Near Earth Objects project when Lowell's pioneered all of that in the 60s. And he has a ton of unnamed asteroids that Lowell has in its data bank. And once the IAU has verified that any one of these asteroids has a reliable orbit, then the Discovery Institution can give them names. And so for 10 years of service, I was honored with having one named after me. So that was quite a thrill, completely unexpected.
Yeah.
So I've got my rock out there somewhere. I tried to image it last year. Unfortunately, it's smack in the middle of Sagittarius. So even if I know its coordinates, there are going to be a zillion little dots around it. So
Link comparator.
That's right. That's what I need. They don't make them anymore. Yeah, that's exactly what I would need. And we don't have that anymore either because it was held by the Smithsonian, the Blink comparator, for the past 3-4 years. And it's only being repatriated now because, again, it's a historical instrument, So
good for Lowell and the Smithsonian.
Yes, it is. Absolutely. Absolutely.
Well, any more questions before he goes? I'll clap since no one else has their microphones on.
Thank you. Appreciate it. And let's do it again sometime.
Please.
All right. Bye now. Take care. Stay safe.
That would be a first for me. All right, out of everyone else who's left, any questions or comments or problems of the club that you want to discuss? Wow, such a lively bunch. All right, would somebody email Eric to let him know that the meeting has finished?
Yeah, just make sure that we get
I'm here.
our meeting minutes coming up soon too.
The what?
The meeting minutes for the last 2 meetings.
We talked about that with Pete. He said he would